Hello, beloved viewers. My name is Sarah Grace Henry, and I'm the leader of this group. So, my team and I actually made this video for our own learning progress so that we can understand the topic better. And our topic for today is injective functions in discrete mathematics. Injective function, as we know, is one-to-one function where every distinct input leads to a unique distinct output. If you think of a function as a machine that takes an input x and gives you a result y, an injective functions will guarantee there's no two different inputs ever produce one same result. For example, function x equals to function y, then it is true that x equals y. If you ever find a case where two different inputs, which is x and y, gives the same output, then the function is not injective. A great way to tell if a real-life example is injective is to ask, if I can get result, can I trace it back to exactly one source? We actually can relate this function in real-life situation, such as assigning a social security number, SSN, to a citizen. Each person gets a unique number. If you have the number, it points back to exactly one person only. This thing also applies to phone numbers, IP addresses, product records, etc. etc. Now, if you guys would like to know deeper into the calculation, I will pass this camera to my friend.
Hi, my name is Nur Azreen, and in this section I will explain the mathematical concept of an injective function using a simple mathematical scenario. Let f, a from b, be a function. The function f is called an injective or one-to-one if each element in the domain maps to a unique element in the codomain. A function is injective if, let's say, f function a is equal to f function b, which also means a equals to b. This means that if the output is the same, then the inputs must also be the same. Consider the function f function x equals to 2x plus 1. Assume that fa equals to fb, then 2a plus 1 equals to 2b plus 1. Subtracting 1 from both sides gives 2a equals to 2b. Dividing both sides by 2 gives us a equals to b. Hence, the function fx equals to 2x plus 1 is injective. Now, consider a mathematical scenario related to user registration. Let u be the set of users and n be the sets of username. We define a function f from u to n where each user is assigned exactly one username. The function is injective if, let's say, f function u equals to f function v, which also means u equals to v, which means no two different users can have the same username. If two different users are assigned the same username, then u does not equals to v, but f function u is equal to f function v, which violates the injective condition. Therefore, the function is not injective. That is all from me. Thank you.
Hi everyone, my name is Jacqwinson John, and in this video, I will explain about the flowchart for the account registration. So first, the process starts at the start symbol. Here, the system asks, already have an account? If the user selects no, that means they are a new user. They need to enter their full name, date of birth, phone number, and email address. After that, they create a password. Once the account is created, they can proceed to log in. Now, if the user selects yes, meaning they already have an account, they just need to enter their email and password. Next, the system checks whether the user credentials are valid. If the credentials are correct, the user will be logged in successfully and the process ends. However, if the credentials are not valid, the system will ask, forgot password? If the user chooses yes, they can reset their password and try again. If not, they return to the login step and re-enter their details. So basically, this flowchart explains the full process of account registration, login, and password recovery. And yup, that's all from me.
So now, we are looking at a common piece of any website, the account registration system. But we aren't just looking at the code, we are looking at the fundamental math concept that makes databases work, which is injective function. Here in VS Code, I have scaffolded a basic registration page. We have filled for a username, an email, and a password. Now you'll notice the back-end logic is actually incomplete. I have intentionally left out the validation checks and the database insertion. So what does this have to do with math? Essentially, if the outputs are the same, then the inputs must have been the same since Injective is a one-to-one function. In our registration system, we want our email address to behave like an injective function. Think about the input as the domain, which is the person signing up, and the output is codomain, which is the entry in our database. For this system to be injective, two different people should never be assigned to the same account record. For example, if Ali and Abu both try to register, the system must ensure they don't end up sharing the same user ID or email slot. Right now, our code is broken because it lacks a uniqueness constraint. Without a check to see if an email already exists, my function isn't strictly injective. It would allow two different users to map to the same email address in the database, causing a collision. To fix this and make it true injective mapping, we would need to add a conditional check, a guard, that rejects any input if that output is already taken. So, the conclusion of our code, it is not injective.
Hello everyone, my name is Nuraleya Farhani and I'm going to list down the domain and range in our website system, which is account registration. In our system, we use email as the domain and the password as the range. This means each email only use one password. Not two emails use the same password. And lastly, every registered account is uniquely identified. So, the email is XSX, which is F bracket email equal to password. This shows that our registration system follows the concept of injective function because each email maps to a unique password.
And you guys might be wondering, why does it matter? Injectivity is a green light for reversibility. If a function is injective, you can always work backward from the output to find the exact input that created it. This is why injectivity is a requirement for a function to have an inverse. In fields like cryptography, injectivity is vital because if you encrypt a message, you need to be 100% sure it decodes back to the original text and doesn't turn into two different possible messages. Before I end this video, I hope you guys understand about injective functions well and we can use it in everyday life. And don't forget to leave a like and subscribe. Bye!